Hi everyone, I'm Micaiah, and this is my lab report, Charge Tapes for Physics 2212. So a little background on the lab. We were expected to create a net charge on pieces of Scotch tape and measure the excess charge on one piece of tape by observing different interactions. The goals of this lab consisted of gaining a better understanding of the electric force, better known as Coulomb's law, between everyday objects and how electric fields affect matter, as well as visualizing the concept of the transfer of charge. Here are my results that I gained from this lab. I identified the sign of the charge of the Scotch tape to be positive, and this charge is within the same magnitude as the textbook example. And I created a virtual representation of the experiment by adding functions to calculate charge and using previous functions from labs to find the forces. Here are my measurements. I measured the initial height of tape B before I introduced tape A. And when I introduced tape A, the repulsion between the tapes increased the distance of tape B to move away from tape A. So some observations I made. The charged tape was attracted to the negatively charged pin, which meant that the sign of the tape was positive. The net force on tape B is zero since the tape didn't actually float. The center of mass moved slightly, and it moved because of the repulsion between the pieces of tape, which made it float. So here are my calculations. I had to do some unit conversions to get into standard units. And notice that the gravitational force and electric force are the same magnitude but opposite in direction, which makes sense since the net force on tape B is zero. And using this knowledge, I set the two equations equal to each other in isolated Q and used the information I gained to help me find the charge, which is 1.374 e to the negative 8 coulombs. When I was doing these calculations, I ignored air resistance, treated tape as a point particle, and knew that charge is evenly distributed on the surface of the tape. So here are my ratios. The number of electrons on tape B is the resultant charge, which I mentioned, divided by the electron charge, and the number of atoms on sticky side of tape is the tape length divided by atom's diameter, and the ratio of electrons to atoms is the first answer divided by the second answer. So here is my code. You can click on this link and it'll take you to my computational model, and here you can interact with it. So notice this is tape B. The orange arrow represents the electric force. The green arrow represents the gravitational force. And notice on how tape A, you can only see one arrow, which makes sense because of the reciprocity of forces. So in actuality, there are two forces acting on it, but they both have the same magnitude and go in the same direction. And you can click View this program where you can see the knowledge behind my model. So what if electrons had a positive charge and protons had negative charge? The sign of the tape would change, but everything else would be relatively the same since all the signs are reversed. So charged objects still attract neutral objects, and the U tapes would still repel each other. So the laws of physics aren't broken. So why is it important to handle the charged tapes as little as possible? I faced this problem, and when I kept continuing to touch the tape, the transfer of charges through contact would cause the tape to lose charge. So interactions didn't happen as expected. U tapes no longer repelled each other, and the tape wouldn't be attracted to my hand or other objects. So in conclusion, the lab helped demonstrate the transfer of charge between everyday objects, visualize Coulomb's law, and Newton's third law, the reciprocity of forces with the electric force. I was successful in calculating excess charges. Thank you for watching, and I'll come back with more physics fun.